everybody. Can you see me live? Hi, everybody. Can you see me live? If you're here. Okay, super cool. And can you hear me as well? Can you hear me? Okay. All right, sure. Great. Fantastic. That was a little rough starting. They changed everything on, I'm not surprised. They keep on changing everything. So, welcome, everybody. Let's hope that we can save this thing, that we know how to save it after. Wow. Everything changed on Facebook as usual. They change everything. Nothing works the way that it used to work. So let me start by saying that thanks everybody who is joining. I really appreciate it. It's going to be a little bit perhaps longer than 1 hour. I'm going to try to cut it as short as possible, but there are so many people asking so many awesome questions, and we have a lot of new members. And so I want to make sure that all the new members um, are appropriately sort of introduced into our system, and also want to answer all the questions that were asked previously. I took lots of notes, and I will try to recreate some of my notes and present it in a presentable form, and post it up for you to read it later. And of course, any questions that you will have, I won't be able to answer them during the video because I don't actually see much. I see your comments, but I don't really see too many things here. So what is going to happen is when you post your questions later, then I can just answer them in the group, and then of course we will have future Facebook Live videos as we've had in the past. So that should be all right. Okay. So welcome everybody. Let me start with a very complicated topic. This is something we usually we just send the new members to the units, have them look at everything that there is to know about plants and anti-nutrients. But I wanted a little bit more information, and there are so many new members coming in from the Nordic countries where they push the plant-based diets, and we have a lot of new members who already have told us that they are plant-based, that I wanted to discuss a little bit what it means to be plant-based, and outside of being a migraineur, because being a migraineur, yes, that's a problem, but we have additional issues with plants. So you don't need to be a migraineur to have problems with plants. So the first thing that I wanted to discuss is, of course, what are plants, and then the anti-nutrients, and a little bit of introduction to our digestive organs. So let me start with the digestive organs so that everybody can associate a little better with what I'm going to say about plants. So our digestive organs, of course, are our stomach and our intestines. They're the small and the large intestine, and then we have the colon. So we have basically three distinct parts. Let's keep it that way. There's the stomach, the intestines, and then there is the colon. In an animal that is meant to eat plants, the stomach, if there's only one, usually there's more than one, there could be two or four stomachs, those are not really highly acidic stomachs because the animal is basing on its digestion on fermentation via bacteria. And the bacteria can be in the stomach, can also be in the intestines, and can also be in the gut, in the colon. And so in order for an animal to be able to get nutrients out of plants, it needs to ferment, because plants, by and large, are made of cellulose. And cellulose, think of it as when you pick up a piece of grass and it's kind of hard to tear. It's because the cellulose is an extremely hard substance. When the tree bark around the trees is actually cellulose that is dried out. And so cellulose is the equivalent to a human or an animal cellular membrane. So it forms a membrane around the cells themselves, so they're hard, firm, whereas in an animal the cells are very soft and pliable. In plants they aren't. They are meant to be strong so the tree can stand, the leaves can sort of take up a position and collect the sun rays. And so the role of the cellulose is not to be digested per se, but to hold up something erect, like the bones of an animal. Okay, and so we can't digest cellulose, or acids are not made to digest cellulose, even though our stomach acid can, hydrochloric acid can digest rocks, but we can't digest cellulose. This just tells you how hard cellulose is. And so, in order for us to do anything with plants, we are relying on bacteria. The other parts of plants that we can use are the starches and the carbohydrates in general. So, when we're talking about plants, excuse me, my lip got chapped. So when we're talking about plants, we're really only talking about consuming those things that we can digest, that we can metabolize. So we're talking about just carbohydrates. There is protein in plants and there is some fat in plants, but the protein in plants are not animal proteins. And by this I mean it, even though there are only 20 digestible proteins for animals and humans in general, and plants have some of those proteins, they don't have them, they don't have all of them, because their proteins don't need to create bones. Their proteins need to create other things, right? So the function of the proteins in the cell is to support the cell, not to support the animal that is going to eat it. And so they don't have those kind of proteins that we actually need. They Most plants have many, but not all. Only one plant, a single plant, which is a soya, and we talk about soy later, that has all amino acids or proteins in them. But even in the soy, it's in the wrong proportions. So when you're supposed to have certain ratios within certain amino acids to start protein synthesis, for example, you won't find that in plants. You won't find that even in soy. So if you want to create a plant-based diet such that you can actually thrive, you have to combine those plants extremely carefully. And so here we're talking about just one thing right away that is a problem, is that plants don't provide the nutrition that we need. Because in terms of our digestive organs, when we talk about the stomach and the intestines and the colon part, the only part we can literally do anything with plants other than carbohydrates is in the colon. In the human body, the stomach is about this size and it can become quite big as we eat, but it's not meant for the digestion. As we said earlier, it's meant to digest meat. It's not meant to digest plants. Then the intestines are this referred to the smaller digestive organs, which take up the most space actually in the human digestive system. They cannot absorb anything from plants other than carbohydrates. So when we're talking about digesting of plants, we are really referring only to the very last segment of our digestive organ, which is in the colon, which is about this big. It goes up like that and comes out and goes out through the anus. So we're talking about the very last segment, which is also the biggest. And this part of our gut is filled with the gut flora. And so we don't actually digest anything in the colon. The only thing we do really is absorb water back in that we use all through our intestinal system for absorption. And whatever water is left in the food, whatever food there is left, then we can reabsorb. And so we don't have diarrhea under normal circumstances. But this area is really not an absorbing area. So in this area, we only have the bacteria who then do some fermentation, and their end products, in other words, their poops, are what we then use. We can absorb as short chain fatty acids, which are called butyrates. And so those of us who are on a low carb diet or carnivore diet or the ketogenic diet are in ketosis. And what do we create? We are creating hydroxybutyrate, beta hydroxybutyrate. And I just said, what did the little gut flora create? Butyrates. So we don't need to wait for the gut flora to create them. We actually make them ourselves. So it's just a proper eating. If we eat human specificity way, meaning we eat the food that we were meant to eat based on our digestive organs, then we create the beta hydroxybutyrate and we're eating perfectly healthy and we don't need to have any plants. So now we covered the digestive organs, so you understand a little bit that humans are not herbivores and they aren't meant to really eat plants. We can eat plants, but that should not take up our dependence on proteins or fats. It's only carbohydrates, and we don't actually need to eat carbohydrates because we can make carbohydrates. So let's talk about plants and why plants are so unhealthy for us. Okay, it's very hard to associate plants with us as being unhealthy because we are told that we should eat plants. Plants is the healthy way to eat, and we cannot have a meal without plants. And plants provide all these nutrients, as vitamins, as minerals, etc. And if you look in the USDA database, you're going to see that indeed plants provide a lot of minerals, calcium, B9, for example, folate, a whole lot of vitamins and minerals, vitamin C, come in from plants. But the question is, are they really truly nutrients we can absorb? And the answer to this is a resounding huge no. And this is very important to understand, that we can't actually absorb these nutrients. And why not? So think back, what does an animal do when we want to eat it? It wants to run away, or it's going to bite us or fight us, kick us. It will do anything possible to protect itself. So what does a plant do? It's going to say, hey, here I am, just eat me? That's not exactly a reproductive strategy that would work for a plant, because that would very fast lead to an extinction. Yet plants are here. So clearly they have an evolutionary trick up their sleeves that already tells us that they're doing something that prevents us from eating them to extinction. Maybe we ate a lot of animals to extinction, but we haven't eaten a lot of plants to extinction. In fact, we're creating more and more plants. And so what are some of the problems with plants? So plants create a lot of good stuff for themselves to survive. And they create one particular element that we should be eating, that they want us to eat, and those are the fruits. And that's because the assumption of the plant is that we eat the fruits, and then of course the seeds don't digest. I already said we can't digest anything that is cellulose, and the seeds are really bound by cellulose every which way, and a lot of anti-nutrients, which I'm going to talk about in a minute. And so the idea is that when you eat the fruit, you eat the seeds, and then you poop out the seeds, and then when you defecate somewhere in the wild, like other animals do, then a tree can grow, or another plant can grow, and so it can reproduce. So the plant wants us to eat the fruit, but it certainly doesn't want us to eat the leaves, because if you do, we just took away its source of energy, right? The plant is using its leaves to take energy from the sun and to convert that energy into nutrients that it needs. It doesn't want us to eat the leaves. So eating lettuces, eating spinach, eating all kinds of teas, whatever you're eating that is a leaf, already tells you it is not meant to be eaten. And so there are some problems associated with eating leaves. How about eating tubers or roots or nuts and seeds? Same things. The roots, obviously, that's the base. It's like somebody's trying to cut your feet off. The plant will die without it. So you can't take the roots. So the roots and the tubers are roots as well that store a little more nutrients for the plant for a rainy day. So if you want to eat that, then you will have a consequence you have to deal with, because it is going to be filled with anti-nutrients, because the plant doesn't want you to eat that. And so what it wants to do is to make you sick just enough to not touch it the next time. It doesn't want to kill you. The problem is if you keep on eating this stuff, and we do, because now we can deliver the plants by transportation very easily. In the dead of winter, you can have cherries and watermelon. So this is a problem. We aren't supposed to be eating this way. And so we are not eating too much of it. So if you're eating one bowl of spinach, for example, once a month, that is not likely to harm you nearly as badly if you're eating it every single day. And if you're juicing it, that it's definitely going to harm you. So let's talk about some of these anti-nutrients. There are a lot of anti-nutrients, and I found an article, and I will send you the link to the article later after we finish the discussion. And I'm going to be reading this because some of these are extremely complicated and I haven't memorized them all. So we have a lot of, I think, 11 anti-nutrients that this particular article is talking about. So let's talk about lectins, because lectins are in just about everything. And lectins are a kind of a protein. They're sort of kind of a glycoprotein, meaning a protein that attaches to glucose in some way. And so they will basically, as like polysaccharides, meaning starches, but many, poly meaning many. And so their function is really to recognize very specifically carbohydrate within an animal cell. And they will disrupt the process by which we can absorb the carbohydrates in the nutrients that we eat through interrupting the cellular mechanism of carbohydrate absorption. So what it specifically says that it bypasses a lot of human defense systems, because many of these proteins can mimic the same kind of a protein structure. These are not proteins that we would be eating. So these are not the 20 amino acids we would be eating. These are different proteins that the plant creates from those 20 amino acids. And so this kind of a protein is similar, like we humans create a lot of proteins, like homocysteine is a protein. And so it's just a protein. So our defense system may not recognize that this is an alien defense system. And so it can then travel through the body and disrupt the carbohydrate metabolism all through. And some of the diseases it causes, of course, are Crohn's disease. It can cause literally holes in the walls of the gut. The gut is all through the intestines and the colon, as I discussed earlier. So that's gut, refers to it in whole. It also causes leaky gut syndrome. So it increases the permeability of the intestines. And so that can cause a lot of problems. It can also cause colitis. It can participate in celiac disease, although it isn't celiac disease, but it can predispose a person to be sensitive to grains, etc. And grains, by the way, are very high in lectins. And so obviously, lectins are a great cause of autoimmune diseases as a result, because they also, believe it or not, stimulate the growth of white blood cells, okay? And the white blood cells are our immune system. So we are talking a double whammy. On the one hand, they disrupt the system, and on the other hand, they cause it to react more violently to whatever disruption it caused. So lectins can actually kill. Some of the foods that are high in lectins are like beans, of course, legumes, but also grains are very high in lectins. Another one that is less often discussed are trypsin inhibitors. Trypsin inhibitors are really very powerfully inhibit protein digestion. So if you're eating a lot of plants and you're eating also protein, and we already have in a graph in the group about, I believe it was oysters, that if somebody's eating 120 gram oysters, and I'm not saying that you should eat oysters, but that was the example, it will have so much protein and zinc available in it. And then if you eat it with beans, what happens? And if you eat it with grains, what happens? And we could see how it disrupts the absorption of zinc in this particular case from the oysters. But if you're eating beans, for example, and you eat it with a steak, or you're eating trypsin inhibitors in one of these foods that contain it, which would be all the plant matters, then it will block much of the protein that you could be absorbing from the meat. This is one reason why I always ask, when you look at the leucine threshold, if you met your leucine in your diet, is to only look at the meat or animal product leucine, because if you also eat plants, this will even be lowered as a result of the absorption, plus whatever protein you eat from the plants, those proteins don't absorb. So you need to be careful about what you're eating. So we have trypsin inhibitors that inhibit protein digestion. We have what's called the alpha amylase inhibitors. The alpha amylase inhibitor blocks insulin release. This is very important. It can be used, and it has been used, for example, to reduce the absorption of glucose. And it can do that because by blocking insulin release, it actually increases glucose, so it failed. So it can't really do that. There have been a lot of experiments, and there was a lot of belief, but actually it failed because it blocks the insulin release, and thereby increases glucose. And not to mention how much trouble it may cause with your pancreas, which is trying to release insulin, right? So it interferes with your pancreas's work. There are protease inhibitors. So protease inhibitors are very, very common. They are part of just about every single legume, especially soybeans. And a lot of people who are on a plant-based diet eat a lot of soybeans. But soybeans are filled with protease inhibitors. And so they actually, enzymes that affect every single key cell process. So they bind to, they target protein. So take any human protein within the body, and I'm not talking about the animal proteins that we can eat, the 20 proteins, but the proteins that we create as a product. Like for example, many of our cells, most of our cells have proteins in them. There's a protein that's around the cholesterol molecule. There are proteins that are necessary to build the 40% of our bones are made of proteins. I'm talking about these kind of proteins that literally make up our body. And so here, the protease inhibitors bind to these proteins. And this article is very clear that this bind can be reversible or irreversible. So when you're eating a lot of soy and then you switch to another diet, say a carnivore diet, and you're having a really difficult time generating enzymes that can allow you to digest your food and to absorb protein, that may be because you're irreversibly damaged your ability to do so as a result of having eaten a lot of soy. Tannins kill. One of our videos in the units is about how tannins kill tens of thousands of animals because plants communicate. Tannins are released when an animal is eating too much of that plant. So, for example, if you buy head of lettuce, the kind that grows with roots in your refrigerator, and you take a little bit of it and you put the lettuce back into the refrigerator, the next day, the next bite of lettuce you take will have a lot more tannin in it because that lettuce is alive in your fridge. It has roots, it's living, but you took half of it off. It doesn't want you to eat anymore, so it will increase its tannins and it will harm you. It can kill your liver. And so tannins are really what it says is impair the digestion of various nutrients and prevents the body from absorbing bioavailable substances. So it blocks your ability to digest and metabolize the other foods that you're eating as well. And it deactivates your digestive enzymes, in addition to the fact that it's so toxic it poisons your liver. Phytates. Everybody says phytates are great. Let's have some phytates. Actually, no. Phytates are the very things that reduce the bioavailability of your minerals. And that is why when you're eating spinach, for example, even though it's full of calcium, you can't absorb any calcium from spinach. And you can't absorb any iron from spinach. You can't absorb anything from spinach. You're just absorbing nothing, basically. And so this is the problem with phytates. And so this is why regulations quite some time ago, came out: don't even feed your children spinach more than once a month because it is harmful. So it blocks all kinds of minerals, iron, zinc, magnesium, and of course everything, because it is binding to it and it is not bioavailable to us. So we can't actually digest it. It robs us from all the vitamins, and it can rob us from more vitamins than what is in the food that we are eating. Goitrogens, we are all familiar. We talked many times about goitrogens. Soy, for example, but other kind of foods are extremely high in goitrogens. Cruciferous vegetables are very, very high in goitrogens. And goitrogens actually cause hypothyroidism. They block iodine absorption. I have a friend who is also in the group who has hyper, meaning too active, thyroid. She is eating now cruciferous vegetables to lower her iodine level, but she doesn't eat any iodine, but she has a hyperthyroid, it's a Graves' disease. She's actually eating them instead of medication. So here you are trying to eat a lot of cruciferous vegetables like Brussels sprouts and cauliflower, broccoli, etc. Cabbage, forget it. They are very high, they're all goitrogens. There's one here that I can barely pronounce. It's called raffinose oligosaccharides. So oligosaccharides are saccharides, and oligo meaning many, similar to poly. So these are very large saccharide or starch molecules that are indigestible. And so they originally started to use this synthesized from sucrose itself. Sucrose is table sugar, so 50% glucose and 50% fructose. And but what happens is that, for example, foods that are very rich in raffinose oligosaccharides are like beans and legumes in general, and they cause a lot of burping, abdominal pain, and bloating, and they can very badly interfere with your digestion. It can completely dysregulate you, and it can reduce how much energy you can metabolize and how much protein you can absorb. So here is something that is very typical that we associate with being okay, like the legumes. because they are high in protein and high in starches, everything, and also high in fiber, everything that's good for us. And it turns out it's actually very bad for us. They block a lot of enzymes that could help us. Saponins, this is something that I haven't heard of before. That is the one that's giving a bitter taste to some of the foods. So, for example, I suspect that Brussels sprouts, something that I can't eat because it's too bitter for me, probably has a lot of saponins, but it's actually toxin, and so it will bind to zinc and a whole lot of other nutrients, and so it won't allow you to digest and to metabolize the nutrients from the food that you're eating, and so it will literally block all the vitamins, all the minerals, everything in the gut. It won't allow your gut to absorb these from it. So some of the foods, other than the Brussels sprouts, that are surprising, legumes are very high. Of course, we're not surprised. Soy is the most well known for saponins. Asparagus, spinach, onion, and garlic. These are very high. Tea, very high. Oats, ginseng, licorice. So there's a whole lot of things in here, very unusual kind of things. So you have to be careful about saponins because they're actually toxins, direct toxins. Oxalates, we all know about oxalates. We talk about it very often. So oxalates are little sharp crystals. They're very, very tiny. They're submicroscopic. You can barely see them with a microscope. And we know that they can cause terrible pain. And there are some people for whom it's no big deal, and there are some people who are terribly disturbed by oxalates. And the reason why I took this out is very important because we all know that yes, there are some foods that have oxalates, and in fact, for example, spinach is very strong. Almonds are very strong. Blackberries have a lot of them. So there are chards, and some foods have really, really high in oxalates, and we can avoid those. But we of course make our own oxalates as well. So oxalate is a natural byproduct of the metabolism. So we can't avoid to have oxalates. But when we eat plants, we increase our oxalate load. If we eat only animal products, we don't, because whatever meat we eat, except for the liver, it has a little bit of oxalates in the liver, but the other, maybe muscle meat, it doesn't have any oxalates in there. But we create our own oxalates. So the problem happens when we create or take in exogenously from plants more oxalates than our body can literally remove. So we can remove some oxalates without any problem. Like I don't have any oxalate issues. I can remove oxalates very comfortably. But there are some people, and I read this sentence up to you. It says, in sensitive people, even small amounts of oxalate can result in burning in the eyes, ears, mouth, and throat. Large amounts may cause abdominal pain, muscle weakness, nausea, and diarrhea. There you go. Remember these symptoms because we've been talking quite a bit about eyes, ears, mouth, and throat pain, right? And then we're also talking about abdominal pain, muscle weakness, nausea, and diarrhea. So remember this. So this can be from eating too much plants. Chop those out of your life and you will no longer have that problem. And then the last anti-nutrient is the 11th, is called exorphins. And exorphins are actually really the family of prolamins. Now, prolamins, I have a couple of articles about. Those are like the gluten and gliadin. And then, of course, in corn, in something else, and in rice is something else. But these are all part of this group that are called exorphins. And so what are exorphins? You have probably heard of the word endorphin. So endorphins are substances our body releases to make us feel good. So these would be opiates or similar. These would be chemicals we release when we are feeling great. And exorphins are exogenously provided substances that make us release endorphins or make it mimic as if. And so this is why when you read some of the books, such as Wheat Belly and others, they will tell you that grains are addictive, and in fact they are because they release morphine-like substances. So these are exorphins. They're opiate-like, morphine-like substances that they release into the gastrointestinal tracts, and so we feel great when we eat bread, but we're actually just ate a whole bunch of opiates and similar. So is that good for us? No. So it is something that people, for example, who often react to dairy, like milk, will literally react to the exorphin effect of dairy. Dairy also have exorphins, but not everybody senses that, and not everybody is sensitive to it. But those who are commonly saying, well, I can't have a piece of cheese in the fridge because I'll just go and eat it because I'm just addictive to it. That's an exorphin. So that's when, because the dairy releases the endorphins, that are opiates, and make the person feel good. So there are different levels of thresholds in people. Like for me, you put a milk there, I'm not going to get any kind of a pleasure other than I happen to like the taste of milk and I will drink it and I will feel satiated if I have milk with cream in it, but it doesn't make me go and have another glass. So those of you who feel that you have a lot that you want to eat or drink cheese or eat cheese all the time, you may have this particular response, which is called the alpha casein derived exorphin. So it exists in dairy. And so some people, though, have a problem with this particular product and they react to it and they get a gastrointestinal reaction to it, inflammation, and they feel really bad from it. And so they may have a reaction to it without being lactose intolerant. So not all reaction to lactose is from the lactose itself. It could be that this person is sensitive to this exorphin. So with this, then you understand, and this was at the end of the anti-nutrient list that I have based on this article. And so you can see that we have a lot of problems with eating plants. And so those of you who are just joining the group and or have been with us for some time and are eating a lot of plants, particularly if you're eating a lot of green leafy veggies and a lot of seeds and a lot of tubers and nuts, that could be a lot of trouble. And while they don't cause migraine per se, they can cause a whole lot of health conditions and, of course, a lot of stress on your system, which then can lead to migraine. So if you are on a higher plant-based diet or on the protocol and you have some of the problems that I have listed, then you're probably better off if you reduce those plants or quit eating plants completely. And you can have just eat the fruits like I eat on protocol these days, and I eat just fruits. I don't eat a single plant. So you can manage by eating raspberries and strawberries perfectly well and have milk, and you have mat oil carbohydrates perfectly well. You don't need to eat any green leafy veggies or cruciferous veggies or tubers like potatoes or sweet potatoes or nuts and seeds or legumes to get your carbohydrate levels up. And if you can do without carbohydrates beyond a carnivore diet, that's the best elimination way that you can actually discover what your problems are, because you have eliminated the biggest irritant from your system. So now with this, I want to switch over to answer questions. So let's see where we are in time. So we're about half time, so that's pretty good. I got a lot of questions, and some of them will be short answers and some of them will be longer ones. So here, the first one is from Tatiana Zakariodou. I'm sorry if I don't pronounce your last names well. So she says, I'm on the protocol for more than 1.5 years, and I end up eating the same allowed and tolerable vegetables or fruits in rotation. How bad is it for my health, since inevitably I will eat the same nutrients and vitamins? So already I answered part of this question, and that's why I put hers first, because I just said that there are no nutrients or vitamins coming into us from plants too much. So if you want to have nutrients and vitamins, we are getting those from animal products. So eating plants, whatever you eat, the things that you have to look for is to look at eating those plants that inhibit the least amount of nutrients from whatever food you're eating. And at this point, I would recommend that only to be fruits. And the fruits will not inhibit any of your nutrients, so you can eat as much as you want. I would not recommend that you rely on any nutrients coming in from plants. They won't be. Even from fruits, you're getting some potassium from fruits, and that can absorb, and you're getting also some vitamin C from fruits. The problem with vitamin C coming in from fruits or plants is that, vegetables that is that you can't actually absorb that C. Vitamin C is made from glucose. It's a change of one molecule. So it has the same receptor. The two have the same receptor. So glucose or vitamin C both are in the same place at the same time, and your body has to make a decision which one to absorb. Is going to absorb the glucose, because glucose is toxic. what's going to happen to your vitamin C? It's going to urinate out. And vitamin C excess converts into oxalates for many people, not necessarily everyone and to the same degree, but it is well known that vitamin C converts to oxalates. So if you are taking a lot of plants, you really need to eat thiamine, the B1 that we recommend, which is the L-theanine or lipothiamine or TMX, because these are the only three that really truly can absorb, and thiamine can offset the oxalate formation. I don't know the mechanism and it's beyond the scope of this discussion, but in hospitals, for example, during COVID time now, whichever hospital is providing vitamin C to the patient will also provide thiamine to prevent oxalate formation. So Carol Alcote she asked me to talk about metabolic disease and where we tie in. And we're going to return to metabolic disease a little bit later as well, because somebody else asked a similar question. So metabolic disease, what is that? It's a catch-all term that describes all health conditions, including heart disease, vascular disease, which includes heart attacks and strokes, heart failure. It also includes, of course, obesity, cardiovascular disease. What else? It includes diabetes, of course. It includes both type 1 and type 2 diabetes, but we're really focusing on type 2 diabetes. It basically incorporates all of our modern diseases. And although it stops short of saying, for example, that arthritis is a metabolic disease, I kind of sort of would like to put it under there, because arthritis, cancer, all of these are basically including multiple sclerosis, Alzheimer's disease, Parkinson's, all of these have metabolic connections. And these diseases really didn't that much exist. I mean, there are some cancers that are not glucose-loving cancers, but 99% of the cancers are glucose-loving cancers. So if you didn't eat carbohydrates, we could reduce the occurrence of these cancers, because cancer is just a cell that wants to reproduce. It's an ancient form. It's reverted to its ancient form when it could reproduce out of control without any overriding outside order like we have in our body, which is a multicellular organism. And so everything that we have today that is a non-infectious disease is basically a metabolic disease. So look at it that way. Once you put it, so it's not genetic, such as being born with a condition like one eye, etc. If it's not genetic, and if it is not a contagious disease, then it is likely to be a metabolic disease. So you can put everything in there. Okay, of course, also like broken arm, like this kind of accidents, obviously don't fall into this. So when we talk about metabolic disease and where we tie in, we know that we are genetically predisposed to be unable to reset our, and let me say the word here, ionic gates. So what are the ionic gates? This is explained in the book in great detail, but I can talk about it a little bit. When we're talking about our brain and our cells, they have to take in nutrients and they have to signal to other parts of the body. They're connected, right? Every single cell in your skin, the cells are connected. And so there's quite a bit of signaling going on between and among the cells. And in the brain, the signaling is happening via neuropeptides, neurotransmitters. Those are little hormonal messengers, if you will. And not unlike that of insulin or glucagon or ghrelin, etc. These are just hormonal messengers such as serotonin, dopamine, choline, and similar. And these messages carry information. So if I smell a flower, it will go through my olfactory bulb into my nose, and it will connect directly to the neurons. And then the neurons will release some message, I just smelled something. And then as this message goes to the next neuron, it's going to pick that up and say, she smelled something, so let's amplify. What is it that she smelled? If you're a regular person without a migraine brain, the amplification is going to be minimal. Big deal, you smell the flower. If you have a migraine brain, you have much more connections between the neurons, and the amplification, therefore, is going to be bigger because more neurons start this chatter. Hey, she smelled the flower. But what happens with these neurons is that they have to communicate such that they can release these little messengers and neuropeptides. And that happens through a voltage current that has to go through the cell. And we know from the book, and I'm sure you remember, that there are through the neuron has the axon, which is like the feet, I imagine, and it has myelination, which are little fats areas that where it's insulated, but in between the insulation there are little gaps, and these little gaps are called the nodes of MBA, and that is where these ionic channels are, the sodium, potassium, ionic pumps, and the magnesium and other kind of things are. And so in these little gaps, at certain given time, as the message is trying to get through, and so the voltage is trying, it has to be recreated at every single point in order for the electricity to go through the cell. Sodium must be available, potassium must be available, chloride must be available, and water must be available as well. Magnesium must be in the cell, ready, attaching to an ATP, which is the energy molecule that the body is creating either from ketones or from glucose. It doesn't matter which one. Okay, it's an ATP. And so when a magnesium is attaching to an ATP, it can open the ionic pump from the inside, and sodium can rush in, potassium can rush out, and so thereby it recreates the voltage at that spot. So when we're talking about a metabolic disease, and this is where it's very important to come to, a brain that uses more sodium, like the migraine brain does, it uses way more sodium than a non-migraine brain does, it will then need more sodium at these little spots all the time. Because if I smell a flower and if I have 100 times as many connections as somebody who doesn't have a migraine, I use 100 times more sodium, correct? But what happens when I eat carbohydrates? We know from the book that I discussed in great detail, and I'm actually quoting from the medical manual, saying that when sodium enters the cell, when glucose enters the cell, sodium and water leave the cell. So what am I doing if I'm eating carbohydrates? And what am I doing with the glucose that comes into the brain? I'm literally stopping my sodium availability in the brain, okay? So what the metabolic disease connection to migraine is not a direct metabolism connection like for a type 2 diabetic. It is a connection such that we can't tolerate carbohydrates because we don't know how to use the glucose in our brain. We have a problem because when we use the glucose in our brain, we actually stop having enough sodium, and therefore this can cause a serious problem. So here's the direct, immediate connection to metabolic disease. But what does this actually mean in terms of the regular metabolic disease, such as cardiovascular disease, diabetes, etc.? It connects very strongly because if I am unable to use glucose with my brain, what is going to happen to that glucose? And what is going to use that glucose? What am I going to need to actually do with that glucose so that it goes away, that is going to be used by something? We know the most amount of glucose in our body is used by our brain, right? So if my brain can't use it, what do I do with it? I can certainly run a marathon, but do you? So there is a problem. So then we have a bunch of glucose that we don't know what to do with. It's not going to be used. So what is going to happen to it? It's going to be converted into fat, and it's going to be deposited into our liver. And this is where the non-alcoholic fatty liver disease comes from. And that is a metabolic disease. Okay. So when we have deposited a lot of fat in the wrong places inside the organ or right around the organ, then we're talking about major problems, and we're talking about an imbalance of metabolic health. So it may not be that it will cause, that our migraine brain will cause us type 2 diabetes, but given all these conditions put together, it may. And so what we find with 99% of the people joining the migraine group is that most everybody has some form of metabolic disease. It may not yet be full-blown type 2 diabetes, but it certainly is the start of type 2 diabetes or insulin resistance, and some already at the very end, nearly converting into type 1 diabetes. So we tie into the middle of metabolic disease with our inability to utilize carbohydrates or glucose the right way. At the same time, and I have to add here, is that whereas the general population has a hard time falling into ketosis, and they fall out of ketosis very easily, migraineurs fall into ketosis very easily. Everybody in on the protocol diet, which is really just a low carb high fat, everybody is in ketosis. This isn't so with the general population. Putting a regular person without migraine brain on the low carb high fat diet will not put them into ketosis. And if they eat one single food element with a little bit higher glucose than ketogenic diet will allow, they will be out of ketosis. Show me a migrainer that ever falls out of ketosis who is deeply normally in ketosis. We never do. I can eat a whole watermelon, and I've tried it to see at what point do I fall out of ketosis. And even a whole watermelon, it will back up my ketones. It tells me that yes, I am using glucose at that time when I'm digesting or metabolizing that big amount of carbohydrate. So my ketones will increase in my blood. And then what am I going to see? Within about an hour, all the glucose is taken out of my blood, and I'm back into ketosis just like nothing ever happened. And so for us, our metabolic system is so different that we can't go by the standard definition of metabolic disease that is used for other people. We have to have our own definition. So then Kelly Lisa asked here, she says, I was wondering about our brain configuration. This is very interesting. She says, if we are not born with a migraine brain, but born with migraine gene, which will be activated once switched on, does our brain physically change when the migraine gene is activated? And the answer is yes. So the way this works is that as the migraine gene is activated, the brain starts building up these extra connections that I have just discussed. So a regular brain that doesn't have migraine genes will create, I'm just going to say a number now, for each sensory axon and a sensor or neuron. And a sensory neurons are your nose, your eyes, your taste buds, of course, your ears, and also your touch and feel. So we're talking about 5 different senses, and they're all connected to neurons in the brain. The question is, how many other neurons are these neurons connected? So the connection among neurons. So if you're looking at a regular everyday person who doesn't have our brain, the neuron coming in, for example, from the nose, connecting to other neurons will be, I'm just saying a number here, 10. But when you're looking at a migraine brain, it's going to become a lot more, say 100. Again, just a number, just saying something here to give a differentiation. So we have so many more connections among the neurons, and this is a change that drives migraine. This is the reason why we are having migraine brain. And so if the migraine brain is switched on, then that means these neurons are increasing in connection to other neurons. And so this is one of the reasons why most people start migraine slowly, and then the migraines increase as we age over time, in intensity as well as frequency, and also in general the length of migraine, for example, is going to go from say 4 hours to 3 days or 5 days, etc. It's because our brain evolves and it keeps on continuing. It isn't necessarily stopping the increase of the connections, and this is why it is so important to understand that, you know how they say that the migraine just disappears when your periods stop and then you enter menopause. That actually isn't true. It may increase. If your brain is reduced in your menopause or soon after that, that actually means your brain started to reverse. And what does that mean when connections are pruned? Pruning meaning disconnecting. When connections are disconnected in the brain, it's equivalent statement to losing your memory. That is a degenerative status. That isn't something that you wish for. So actually, I personally wish to retain my migraine brain with pain and all until my day of death, because I want to retain my mental sharpness and want to remain as healthy as possible. So my goal is not to get rid of my migraine brain. I love my migraine brain because it helps me in many ways. My goal is to support what it needs so it doesn't hurt, but it remains as multi-connected mode as it possibly can be. And if anything, connect even more. I want to be smarter. I want more connections. Laurie Schaefer Romero asked a couple days ago about the drug reduction for her son, and I responded there, but I wanted to discuss a little bit about, for those of you who are still taking medications that need to be tapered slowly, I don't recommend any medication to be quit, not even triptans, even though triptan is as needed basis. I don't recommend it quitting cold turkey because it can cause huge rebound. So everything that you want to quit, I recommend that first of all you talk to your doctor about it, because your doctor may be able to help you, providing you reduced dose. There may be compounding pharmacy that can simplify your process so you don't have to cut your pills or cut the beads out of your capsules as some people have to do. So I recommend that you reduce everything very, very slowly. And I also recommend to keep something in mind. Every medication has a different half-life. The half-life is the length of time that it takes for the medication to reduce to half, metabolically speaking, in terms of what's in your body. So it is assumed that when half of the medication is gone, then whatever effect it has on your body is just half as strong as what it was before. Whether this is accurate or not, I'm not going to debate, because that's a different story. But just so that you know that drugs that have very short half-lives have to be discontinued differently from drugs that have a very long half-life. So for example, if you're taking a drug such as Valium, something that I was placed on when I was 19 for severe issues that I've been reducing for years as a result, because I've been on it since 19 and I'm 67. Since 19, I've been on this drug and I'm not reducing it. But it has to be taken carefully and very slowly, because your body is so dependent on getting it. It's basically addictive. Not all drugs are addictive, but even if they're not addictive, they depend on it habitually. Similar to, somewhat to like cigarette smoke and otherwise, is that your body can't really function, or coffee for that matter, your body can't function without it. And so without it, it's going to cause some negative effects. And so the longer the half-life of the medicine, the easier it is to taper off of it. And that's because, for example, the medicine that Laura's son is on has a half-life of 29 hours. And what that means is that basically it takes more than a day to lose half of the effectivity of that drug. So if he were to skip a day by accident, that would be not big of a problem, because that second day, there's a second half of the medicine is still in him. But the effect of him quitting the drug is not going to show until the third day, right? So, and at that time, it could be a catastrophic show that, hey, you didn't take this drug and now I'm going to give you a seizure. So you need to be really careful, and you need to be cognizant about not just that you want to quit that drug or get rid of that drug, but how you're going to do that, because some of these medications have very long half-lives, which can be tricky because they might be easier, but they can bite you several days later when you think you're okay and you're not okay. And some other drugs like propranolol or some quicker acting drugs may have a half-life of just a couple of hours. And then you think, oh, well, that's just a couple of hours, so I should be able to quit. But no, because even though the biological half-life is just a couple of hours, the actual active half-life within the body is longer. And so quitting, for example, a drug like propranolol or metoprolol, toprol, which is these are hard drugs, cold turkey, they have short half-lives, and you may think, oh, I can do that. But then the next day, you may end up with a heart attack in the hospital. So you've got to be really careful about how you taper the drugs. You need to look at the length of life. You need to look at what kind of reactions your body may experience as a result. And you need to also see if there's anything you can do in terms of nutrition to help yourself ease into quitting that particular drug. Okay? The next question came from Chrissy Dasher. She says that I stop my salt water during my cycle. Some people need to stop the salt and water because they have a chloride surge. So look under units for menstrual preparation. So she happens to be one who stops her salt waters during the cycle. But when her cycle is over and she returns to her salt going, her weight goes up a couple of pounds. And is this from the cells holding onto water and making up time from not salting for a few days? And the answer is yes. And there is another question from another person who asked a similar question where she just increased the salt but not the water, which is the same in this case as well, since you're not changing the amount of water that you're taking. When you just drink just water, it's not going to be held onto your body. So this is also part of another question, how the kidneys eliminate the excess. So if you just take a lot of water in, but you're not taking in salt, the water doesn't stay with you. It actually will leave really quickly, within 12 minutes usually. the body, the kidneys eliminate it via the RAAS, which is the renin angiotensin aldosterone system. All extra water is going to be eliminated because your electrolyte osmolality, which is the density of the minerals in the electrolyte, will be diluted by the extra water without the salt and without manipulating it the proper way. And so your body will, within 12 minutes, your blood is about 5 liters and it goes through your system within, I believe, 5 times an hour. And so within 12 minutes, that extra water will be dumped into basically your bladder, and it's waiting to be eliminated. So yes, when you start taking salt after your cycle, you are going to gain weight because now you're holding onto the water as you should be. It increases back your blood volume. When you stop taking salt and you just drink water, and of course the potassium as a result of the chloride surge, then you're actually reducing your blood volume. That's the way it works. Joycelyn Dean Sass is asking me to talk about COVID-19 and the kind of vaccines. Okay, so this is a big can of worms. So let me just tell you what I know without telling, who should do and what. I'll explain the pros and the cons in all the types that there is. There are 3 basic types. There is a type that is very similar to the common flu vaccine, which would be taking a little part of the virus, just say taking the leg of a virus, so it's not able to cause a disease, but it is enough for the immune system to recognize that there's a virus in there, and it will help initiate an immune response and eliminate the virus. This is one method. The problem with this method is that so many people who actually have the virus and are ill don't develop an immune response. So clearly, this system doesn't work for this particular virus. It works very well for the flu and for other things, polio, etc. It doesn't work for this one for some reason. We don't know why it doesn't work for it. It doesn't work for it. And in fact, most people, a very large percent of the people, don't develop any kind of an immune response to having had COVID. And those who do lose it within a very short amount of time. Within 2 to 3 months, all the immunity is gone. And it's like you've never had it before. This is very similar to colds, catching colds. And coronavirus is also a cold virus too. There are other cold viruses as well, but half of the cold viruses are also coronaviruses. And this COVID is caused by a coronavirus, right? SARS-CoV-2 is a coronavirus. So it's very similar to a cold in that you can't have an immune system or immune drug against a cold. We don't have vaccination against a cold because our body clears it from the kind of immune structure, which is called the innate immune response, that does not notify our T cells, our killer T cells, and our memory T cells, which would be the adaptive immune system. So we have 2 immune systems. The innate, which is always floating in our system, and it responds to everything we do, including eating food. And so that's why we sometimes get an allergic reaction showing up for some foods. And then there's the adaptive immune system, which only initiates for certain cues. And this is where the other 2 vaccine types come into picture, because they activate these other cues instead of activating the initial immune response from the body. So the first one, and I don't know what company, I think Johnson & Johnson developing that kind of a vaccination. I am not holding high hope for that, and if I have a choice, I will not go for that. I think personally, that's my opinion, and maybe wrong, I don't know. My personal opinion is that that kind of a vaccine is not going to be long-lived, and they may need 3-4 vaccinations a year. I'm not sure that makes any sense. Now, the other 2 are more interesting. One type is the RNA vaccine. It's referred to as mRNA. The M stands for messenger. So it's an RNA. It's part of the DNA, where the DNA is 2 copies of RNA bond together. So the RNA is just 1 copy. And it's called a messenger RNA because the moment it enters the cell, the cell immediately starts copying it. That's what the cell does. It's the cell doesn't know what it is, whether it came from the nucleus of the cell, which is our nucleus of our cells, where we keep our DNA, and where the instructions come from what to produce, like a protein or other things. Our DNA unravels in that segment that is needed, and a copy is made, and that copy is then becoming an RNA as it comes into the into the cytoplasm of the cell. So the cell structure, but not the nucleus. And so when the RNA comes in from a virus, or it's coming in from a vaccine, or it's coming in from the nucleus, the cell doesn't know any better. It's just going to start copying it. And so it's going to make a whole lot of it. So this is what the virus itself is taking advantage of. So when the virus docks at the receptor and it injects in its segment of RNA, what that RNA will do, it will prompt immediately the cell to copy it. And this is how it kills the cell. And this is why we get sick, because it doesn't allow anything else from that cell. It keeps on forcing the cell to create new replicates of this RNA. So what the vaccines that are currently from Pfizer and Moderna, both of them are this kind of vaccines, they took the RNA that the coronavirus injects into the body, and they kept the most important parts that the body can recognize as, okay, I'm a coronavirus or I'm a virus, but they removed the parts that would instruct the cell to be damaging. And so when this RNA enters the cells from the vaccine, it's going to do two things. One, it's going to force the cells to replicate this RNA, but it's not harmful. It doesn't damage the cells. The cell is just simply making this RNA now. But the cell is very clever. Every single cell, and this is rarely discussed, has a method to tell the world what it makes. If it's making an RNA or protein, whatever it's making, it's going to take a sample of that and will put it on the surface. So if this is a cell, think of it like, say, this is a cell, then there will be a little RNA up there. I am making this RNA. And so this RNA that is going to be up there is going to send a message to the killer cells immediately that this cell is creating something that is viral. It doesn't know that this cell itself is creating something that is not a harmful virus, but it activates the adaptive immune system immediately. In other words, it bypasses the innate immune system and activates the adaptive immune system. And when the adaptive immune system is activated, then it has a chance to keep memory and to remember the virus. So it itself is not doing anything. The vaccine doesn't do anything. It just simply has a means by which it can pretend to be the virus so that it can activate the proper diagnosis so that the body discovers this virus is already in the cell and is doing damage. Let's get it. Okay, so it activates the most important adaptive immune response that bypasses the innate one, which is great because we want to have only the adaptive activated. And it also does another thing. These two vaccines, they also place a copy into the receptor where the viruses can attach. It literally fills these receptors up, because when a virus attached to a particular receptor, it sort of kind of destroys that receptor, so there won't be more viruses entering in that cell. There's going to be no competition between viruses. Okay, do mine, do mine, do mine. So there's going to be a virus attached, and the inside of the virus is going to start producing, inside of the cell is going to start producing the virus. But if there's already a virus there, then this new virus can go somewhere else. And so what is happening is that wherever the vaccine came into the cell, that receptor is going to be then occupied by this imitation vaccine. And so, which is also like a virus cell. It actually looks like that. So it behaves very similarly. And so the cellular machinery, all these receptors are going to be blocked off. And so the actual virus can come in. So there are basically two different functions that the RNA virus can do. And it's important to note that the RNA virus, so the Moderna and the Pfizer, don't actually go into the nucleus of the cell, so they don't modify your DNA. What they're just simply doing is they force the cell where they enter to mimic and create a lot of cells that look like viral cells but aren't viral cells. So they get ready the body for antiviral response really fast. So I think these are very good vaccine solutions. The third one is done by AstraZeneca, which is a little bit different. It's an actual DNA vaccine, which works in such a way that when it enters the cell similarly, and it's a similar method, but instead of an RNA, it is an actual DNA. The cell nucleus cannot, I'm sorry, the cell body, cytoplasm, cannot do anything with the DNA. It can only do something with the RNA. So as I mentioned earlier, DNA is two copies of, that's the helical formulation that you always see drawn. So when you're looking at the DNA, in order for that to be useful for anything, it has to go into the nucleus. So when you're talking about a DNA vaccine, it goes into the nucleus, and in the nucleus, then it separates, and then the RNA comes out, and then the cell can start replicating the RNA. The difference here is that the RNA in the cell came from the DNA. So in the DNA, in the nucleus itself, we have a DNA of a virus mimic. And so this DNA can, I don't know if it was planned that way or by accident, I hope that it was planned that way, can get inside the nucleus and the DNA of that cell. It doesn't mean that you're going to pass this on to your children. But what that means is that when that cell replicates and the DNA splits, if this DNA got into that cell's DNA, which it has a high likelihood to do so, then you may be protected for life against coronavirus. This is a very important point. And I don't know if this is how they planned and what the situation is, but if I had a choice between these three and vaccines to take, I would take this one, because if I have a chance, it's not going to harm me. There's nothing in it to actually harm me. I may have a reaction that's temporary because my immune system is going to react to it, but it's not going to kill me. It's not going to harm me. There's already, I think, 7,000 or 8,000 people have been through the trial, the clinical trial. And in this clinical trial, they don't use placebo. Instead of placebo, they use another vaccine. In this case, they use a meningitis vaccine, a viral meningitis. And so everybody actually got a vaccine, only nobody knew which one. And this is important because when you get a placebo and you don't have any side effects because you're just got saline injected in you, you will know you didn't get the vaccine. But if you got another vaccine, which we know is harmless, in this case the viral meningitis vaccine, you may have a reaction to that, and so you don't know whether you got the flu vaccine or the viral meningitis vaccine. So I, as a clinical trial person who ran clinical trials, I think this is a fantastic trial. This is better than a placebo. It gives me more information. And it can also really truly compare head on one actual vaccine with another vaccine to be. And so I don't know enough about this vaccine, what stage they're in. I don't know enough. But so there are these three today that, and of course, I think that the first one that's going to come out to us is going to be, of course, the Pfizer, which is, I believe, on its way, which is the same as Moderna. Both of them are working on the same thing. So then, next question from Ivy Pejic. How do you manage staying on protocol while traveling? When staying in hotels, going to restaurants, this is very easy. You can carry food with yourself, or you can just ask for food that you know are protocol friendly. So when I go travel, I take with me some food, of course. I will take a steak, I will take some eggs, I will take some cheese. No big deal. You can carry that on the plane. And you can definitely carry it in your suitcase. And you can, even at every airport, you can get a burger. You can get some cheese. There's going to be a Starbucks at every single restaurant, and at every single place I travel to, I can get milk, cream, cheese. I'm set. And if I can't get a burger that is made without bad stuff, heck, I'm going to go to McDonald's and get a burger. Just a burger and nothing else. I'm done. So you can totally stay on the protocol. You can get your lettuce, whatever, on the side. If you're eating vegetables, you can get fruit, obviously. Even wherever you are, you can buy a box of strawberries or raspberries and keep it in the hotel room. I don't see any problem with keeping to your protocol, or to carnivore, or to keto. Totally fine. Missy Gibson Malone asks, weight gain after starting carnivore diet. She says, I was carnivore a year before joining this group and have gained some weight since starting. I'm guessing because of the additional salt, perhaps because I have always drank the same amount of water as I do now. So this is something that I answered earlier with Chrissy, that indeed it's because the water just ran through you. It never retained, it never increased your blood volume. And so now it is increasing your blood volume to what it should be. And so to give you an example, I had a stomach bug 2 days ago, and I emptied as much as I could, and I lost 2 pounds, 2.5 pounds as a result. And it took me an entire day and a half to find that I am returned to my normal weight. It took me that long to drink extra amounts of water that my body retained. Literally, yesterday, I only urinated once, and my body just retained all that salt and water, and I remained hydrated all through being sick to my stomach. So yes, the moment you start salting and the moment you start adding the proper nutrients, you're going to retain that salt and water. Your blood volume will increase, and with that, your weight is going to increase. And you can tell that this is just from water, because if you stop drinking, and I don't recommend that you do, then you are going to lose water weight again. And it's within a day or two you lose it. So it's not fat and it's not muscles that you gain. Alexandra Mihulin is asking, is it normal to not feel hungry and to feel like you don't need breakfast? I force myself to eat my breakfast. I rarely feel hungry, not sure if it's normal. It is absolutely normal, and I should say congratulations, because when you're not hungry, that is the first step toward knowing that you're metabolically healthy. Okay, you're not releasing ghrelin, insulin, you're not hungry, your body is able to supply itself with all the essential glucose it needs. You're also creating a lot of ketones, and you don't need anything other than salt and water. It's totally fine. I today haven't eaten yet. It is already almost 4 o'clock, and I haven't eaten a bite yet. At 3:30, I haven't eaten a bite yet. Just had salt and water, and I'm not hungry. So it's totally normal to go up to even 2 days and not being hungry. I don't recommend migraineurs go any past than that. Now, in the protocol group, we don't allow fasting, and we don't allow you to go without the breakfast if you're on medications. If you're not on medications, and if you had done the 5-hour test, and we could see that you don't have sugar crashes and reactive hypoglycemia, etc., then you need to join our keto group, where in the keto group, you can skip breakfast. In the protocol group, you can't. So if you have done all the requirements, then you're welcome to also stay in this group as well, so you get all the updates. But you're welcome to join our keto group, where you can fast and you don't need to eat at all if you're not hungry. Okay. Karen Tooth, are white matter lesions a result of migraine scarring? An amazingly important question. Thanks for asking that. And I say that yes, it can be. So first of all, what is white matter? White matter is called white matter because it is colored white, but it's actually made of fat and cholesterol. So it's two substances in there, and it's used as an insulation. So if you open the book at part 3 and you look at the photographs or drawings that I've created of the neuron, then you can see how the neuron is myelinated. And earlier, I just explained how the sodium passes in areas where the insulation is missing. Excuse me, I need to drink some water. And this is now just a sip so I can talk. So when this particular myelin is starting to break down, myelin is the insulation of the neuron itself, the axon. The neuron's job is to have a lot of electricity and voltage going through it. But if it lacks the insulation, then what's going to happen? There's going to be a problem, like if two of the neurons touch in a place where there's no insulation, and of course the brain is quite crowded, there's not much space there. So if you have space where they touch and there's no insulation there, you can have a short circuit, and that can cause a seizure. That actually is how a seizure happens. So when you have white matter lesions as a result of migraine, or the migraines are causing, let's put it that way, because you have problems with your brain being able to use glucose. And so insulin and glucose actually disrupt, excuse me, I gotta have salt water. Here's my salt. I'm going to take my official salt and water. There you go. there. Hopefully I can continue now. So when these areas are damaged as a result of pain, as a result of a whole lot of glucose and insulin variability in your brain, then you can end up with these white matter lesions, and it is a migraine scarring. But this can be reversed because we see that people who have seizures, if they get on the ketogenic diet, they can reverse the seizure, they can stop it. So the brain heals. It can be healed. The myelin is a continual myelination process. So it happens all the time. Amber Cable is asking, how did you come up with the protocol macros? I'd love to know the training / science. Okay, so the protocol macros really came out over time as I was studying more and more, reading literature about metabolic disease. I'm sorry, I guess it's myself smoking air. We have a lot of issues with respect to macros at the beginning because we didn't know. We still also ate bread, grains, and we ate some potatoes and stuff like that. So over time, this changed, and we figured out that all these things were bad for us, and this was by trial and error. So there's not much science in this. This is mostly really trial and error, I have to say. This also includes the salt, the amount of sodium that we take, which now, if you look at the 300 milligram sodium that we take, the 1/8 teaspoon, is actually equivalent to the 0.9% saline solution that people get when they go into the emergency hospital and you get a saline IV. So we are drinking what you would be getting there. It's the same thing. So that's how it evolved. It's trial and error, and we sort of kind of ended up with the natural saline level. And the macros, a lot of it was taken, like the low carb high fat macros are pretty standard. And most people in the low carb high fat go higher in macros, in carbs. They go up to 100 carb grams. I personally consider that to be too high. And I cut it short, and I'm afraid I have to cut this out, and so I'm going to respond to the rest of the questions on our next meeting because it looks like I can't talk now. So all the best to you, and talk to you next time.